Hey guys, today we'll be doing LeetCode 23 merge case sorted lists. It is a hard question on LeetCode, and I've drawn up the first example here. So first example 145. So we're given three linked lists in this example, right? And we're given the 145, 134 and 26, and they're given as a list instead of list, right? And we have three of them. And what they want us to do is they want us to cycle through these linked lists. So if you think of it in a way that we have three pointers here, right? And we will compare each pointer. So first we get 1, that's the smallest. Then we would look at our, so if we took this, right, 1, we would take that off, we would put this pointer here, then we would take the next one, which is the smallest, put that here, then we would do the same. So we would take out 2, we would point 2 to be here, then we would take 3, 4, 4, 5 and 6, and that's essentially it. So if you think of it as pointers, then all we have to do is keep shifting until we've traversed all of the lists and we have a sorted linked list essentially. Now the thing with the pointers, right? So if we were given just a general array, not a linked list, we would be easily it would be very easy to keep a track of which pointer we are on. So if we said first is arrays 0 and then the first one, right, and 0 0, and if we were on the second, then we would say go to the second, right, something like this. And we would basically keep a track of these three pointers. There would be a third as well. Keep a track of these three pointers, see which one is minimum, and always append the minimum to the array, right? But it's not so simple in linked list. In linked list, you would basically have to do next, and then you would, in the first, you can't keep a static version of the pointers. Like, you know how we have, like I just showed the arrays, we can just have this, and then we can just have this would point to the first of the first. It wouldn't be so simple, because now you have a pointer and you have to increment the pointer, and so it will get extremely complicated to manage these pointers, check the values, and then move the pointer one ahead, then move the next pointer ahead and everything. So the other way to do it, right, is to actually just traverse through the linked list, store the nodes somewhere. Now this is a hint that I'm giving. Store the nodes somewhere, and a particular data structure is very good at minimum and maximum retrievals. You could store it in that structure. You can take a pause here, think of the answer, but the biggest hint is essentially just we want to store these values, because at the end of the day we just want the values. So you can make the nodes after by ourselves. We can just make we can pass in one and make a node, and then have a pointer point to that. That one is not the difficult part. The most difficult part is getting the sorted version, right? So there is a data structure such that it holds the minimum at the top, the maximum at the top, right? Think of it, take a pause over here. I'll show the answer now. The best way to actually do it is to store a min heap. So if we have 1 1, and if I draw a complete min heap, so if we drew like this, if at the end we would have our min heap, so we would just traverse through the array as is. We would go through list 1, complete 1, complete 4, complete 5, complete 1 2 3 4, and then 2 6 as is. We don't need to bother about the way we are traversing it or whatever, because the min heap will do that for us. Now 1 1 1 2 2 3 4 and 5 6. Now if we pop off the top element every time, this is a min heap, by the way, right? if we pop out the first element every time, we would get 1. So our array would have 1, 1, 2, 3, 4, 4, 5, 6. So 1, 1, 2, 3, 4, 4, 5, 6. And if you see that, it's the same exact one as the one that we would get if we had to, the answer basically is the same as the answer, right? And now we have this. So all we have to do is just make nodes of these values and make a resulting linked list that has these values in store. So the best way we could do it is have a dummy, right? Make that the default, so just initialize it to nothing, keep a current, and then keep the current to the dummy. And just like a normal linked list reversal, you can just do while current, right? While current, or wait, actually in this case we will do it with while heap, min heap. So because we will be popping off, so essentially the heap size will shrink, right? And it will eventually reach 0. That's when we know to stop making a linked list. So I did it by doing while min heap. We will basically pop off our value. We'll make a node. So we will make a node with this value. And then we will make our current. So our dummy right now point to this node. And then we would simply move our pointer one ahead so that it points to the next node, right? And that's literally it. Now I'll write out the whole solution, the way we traverse and we add these, right? Obviously we need to do that as well. So I have the dummy, I have the current as a dummy, that one's done. I will just look through the for ls and lists. So this way I will get, let's say 1, right? Our first thing will be 1. I'll say head equals to ls val head, simply heap q dot heap push into our min heap, the value that we have, and simply move our pointer to the next one. Now why does this work? Because once we have 1 4 5, right, we'll go 1 4 5, we'll go this, and then the next iteration of the loop, the second iteration, will now start at the next one, which is I think 1 3 4, if I'm not wrong. Yes, 1 3 4, and I will just do that, and then 2 6, right? So this would work. Then we already have our current, we have our dummy. Then I would copy the same code. So while min heap, we can just do node equals to, no, actually get the value first, make it cleaner. So we would say value, we would pop off from the heap, so heap q dot heap right, this would give us the node's value. Then we would make a simple node out of it, and we would make our current dot next point to this node, so our dummy would now point to this, and we would make our current the next one. And at the end, just return dummy.next. Why dummy.next? Because dummy.next is the one that stores the first value, so it will basically look like dummy. We would have dummy here, and then we would have 1 1 and so on. So that's why we would return the dot next, so we can get it from 1 and onwards. And that's pretty much it. So the best way to do it, min heap, right? Keeping 3 pointers, because keeping 3 pointers would be difficult, because I didn't even think of implementing it, because I just thought it would be too much of a hassle to keep 3